Hello and welcome back to my miserable little channel, which is steadily growing, as things do. And on the bench today is a new acquisition. It is a Keithley 2015 THD multimeter. Not only is it a 6.5 digit multimeter, which is always nice, it's got the capability to measure THD, total harmonic distortion. Now, I've long coveted one of these. Some of my favourite YouTubers use them. X-Ray Tony B's got one. El Paso Tube Amplifiers has got one. And there's a guy in Australia, Audio Nautica, does a lot of amplifier repairs. He's got one of them. So I've watched videos over the years and always thought I'd like one. But the problem is they were enormously expensive when they were new, and they're still fairly expensive second hand. I mean, at the moment there's several on eBay for anything up to £1,000 from China. Well, I'm not going to buy something from China, not at that price anyway. Not only have you got the problems with getting it into this country, you're going to be paying VAT, import duty, government has to screw you for everything, of course. So I was watching several over the last few months on eBay, but they've always gone for more than I was prepared to pay. And looking at the sold prices of some of them, 400 to 500 is a typical price for a second-hand one on eBay. I'm not sure if you can still buy them new. You may be able to. But anyway, this one came up, and I won the bid. When the seller said he didn't know what it was. There were pictures, and it looked fairly good. It's not, the actual cosmetically, it's not too bad. There is some nasty crap on the front of the display which needs cleaning off. Apart from that, it's fairly clean. But the picture of it working with the display lit up did show some anomalies, which I hoped were not a major problem, but it turns out they are. Never mind, it still works. So the front looks pretty good. Let's try and turn it around. And the first thing to do is get rid of these rack mounting panels, because they're no use whatsoever. A heavy beast it is, and it measures about 14 inches long, which is just about okay to go on a new shelf I put up. So the back has obviously suffered. There is some signs of corrosion. We've got some rust on the screw. Aluminium's a bit tarnished. Typical damp. And these screw holes for the IEEE are rusty. But at the end of the day, I don't really care what it looks like, as long as it works. So what else have we got on here? Because it's a THD multimeter, it's got also a signal generator in it, which comes out on a BNC like that. And I can see there the power selector is set to 220 volts. I might adjust that to 240 if it will do that, because that's the normal sort of voltage we get here. Well, 230-ish anyway. So that's about all you can say on that. And as with most of these multimeters of the standard, you have the option to connect your probes on the back as well as the front, which trigger link, don't know what that does, and I'll never use it. So inverse pulse source output, not quite sure what that does. I don't think it's particularly important. Nice bit of fluff stuck to it, because it's got sticky bits on it and the packing's got stuck to it. But what we're all waiting for, of course, is to power it up, aren't we? So that's what I'm going to do next. Okay, well, we're ready for ignition. Nice squeak, and that's what it does. Now, that display is quite dim. It looked okay in the photographs as far as brightness was concerned, but it's still, I think, quite readable. But if I compare it to my HP, there's a massive difference. See how bright that one is? Of course, when I bought that one, it had a dim display, but I managed to get a new display from China, and that has been very good for quite a few years now. So the Chinese do make some decent stuff occasionally, and we're in DC now at the moment. I don't quite know why it's saying -1 when there's no input. I don't think that's a fault. What I really need to do is stick some probes into it, and amongst this tangle of rubbish I've got some probes somewhere. Wires. My whole life is full of wires. So if I short that together now, that looks a bit better. Now I don't know if you can see it, because I certainly can. Let me get a prodder pointer. If you can see there, there's a sort of digit that sort of shouldn't be there on the bottom half of that segment. Let me see if I can get any closer than that. Yeah, you can see it quite clearly now. Now that, I think, is definitely a fault, and it's got one on that one too. And I don't know what would be causing that. Could it be the vacuum fluorescent? Could it be the driver that drives the vacuum fluorescent? I'll be interested if anybody's got any ideas on that, because I haven't got a bloody clue. And the problem with this multimeter is, although you can download the service manual, which I have done, there's no schematics, so that's not very helpful, is it? You think a company with Keithley's reputation would give you some information on the circuitry inside, but no, nothing. And I'm not sure that would help me anyway. It would be fairly clear what is the display driver, and apart from that, it is quite dim. I'm sure it would have been a lot brighter, but it's still readable, so I'm not completely unhappy with that. And of course, like any other multimeter, you've got DC volts, AC volts, DC amps, AC amps, and continuity, no, ohms, 2-wire ohms, and we're reading 0.15, which is reasonable for the leads I'm using. And if I do shift continuity, I think that means it's set to 10 ohms. No, what did I do wrong then? That I don't understand now. Why is it not working? Okay, perhaps you have to do that. Select it. Interesting. Go back to ohms. Shift. That's a bit tedious, isn't it? Having to do that every time. But it's certainly fast and loud. when we've got 4 wire ohms, so you've got 4 terminals to get more accurate information, obviously. And frequency and temperature, well, I wouldn't use it as a frequency counter because I've got better frequency counters. And if I just touch the leads, I'm getting 2.2-ish megohms. So that's pretty good, I think. 0.1 ohms, fine. And then we've got a lot of other nonsense, which means nothing much to me at the moment, other than the fact that you have to go into measure to set up the THD bit of it. And only measures 3 amps current, which is fairly normal. That's all that my HP does. That's not really a problem, I don't think. And can change the number of digits. Okay. Maximum resolution, obviously. And you can change the counting rate. At the moment it's on medium. So that's slow. And now you can see those digits that shouldn't be there. So that's a bit slow now. Maybe. And that's fast. I don't know if that gives you less resolution. Doesn't appear to. I don't know. I think the best thing to do with it is to stick some DC on it. See how it compares with the HP, because this has obviously not been calibrated for hundreds of years probably. So let's stick a bit of DC on it. Okay, I've got now 10 volts going into it, and I must admit that display problem is quite irritating, but still read it okay. So what's that say? 9.99707. And HP says 99762-ish. So 600 microvolts difference roughly. Who knows which is right, which is wrong. When you get down to those sort of resolution levels, then it's going to show up lack of calibration, isn't it? I could drag in the EEV blog meter, see what that says. Okay, I've gone down to 1 volt now, and that one reads 1.00401, and that one's 1.00409, and the EV blog meter hasn't got enough resolution, has it? Oh well. Can't remember whether it should have more resolution. Let's try something else. No, I can't get any better resolution on that one. Well, they all more or less agree, apart from the odd microvolt here and there. So, get rid of the V blog. That's not really helping. And could try some AC on it. Compare the two on AC. Well, I've got to connect it to a variac, and this one's saying about 11 volts. Of course the variac will vary, as variacs do, because it's not a stabilised supply. So that's 1102 basically. We go up to this one, 1100 something. It's all varying too much to get an accurate measurement. This one does seem more stable, strangely, or whatever. Let's see if I can stick full mains up it without killing myself, because I've just wired them like that to the safe plot. Not the best way to do something, but let's stuff full mains up it. $230 and some annoying bits in the digits, and the other one 230. So they more or less agree. That's all you can say about it, and I think that's pretty good. I don't think I'll bother doing any resistor checks, but I might. Let's see. So I've got a 47 ohm resistor connected to it, and that says 47687. Try it on the HP, and $47,654. Slight difference, but the leads could have different resistances, of course, when you're measuring low values like that. So I don't know if that really proves much, but I think they agree fairly closely. So I'm fairly happy with that one. I don't think I really want to do much more testing. Could test it on diodes. See if I can find a diode. Okay, I have what appears to be a funny shaped 1N4001 silicon diode. Let's test that out. That seems reasonable. Again, it's very annoying having those extra segments lit up. Not very helpful, but readable, I suppose. Wonder if it'll light an LED up. Red LED. It lights a red LED at 1.838 volts. Try a green LED. Not sure what it outputs voltage wise. Here's a rather mutilated one. 1.85, and it doesn't manage to light it up, but it's 1.84. That's okay. Here's an enormous LED. I don't know what colour it is. Oh, it's a white LED. So I can actually light up a white LED at 2.7 volts. Interesting. Oh well. That's about it really. I think what I want to do now is give it a good clean up. Then maybe take it apart and have a look at the display and display driver, if I can find it, and we'll see what happens then. But now I'm just going to disconnect it all and give it a really good clean and get rid of these horrible brackets. Before I clean it, I want to look at this voltage selector, because 220 is a bit low. That's as far as I can see. It comes out like that. And as I've watched other videos, you have to pull this thing out and turn it round. I hope you've got the right, yeah, 240, if you can see that. That's what I'd rather it ran on, then it won't get so upset, will it, and hot. So how does that go back in? Yes, it goes in like that. So that's on 240 now. I suppose it'll do 120 and all sorts of other strange things. Now I'm going to give it a clean. Well, that's the extent of the cleaning on the front panel, but it's difficult to see, but there's a lot of very fine scratching on that plastic panel. Could polish it, but I think it would take the labels off if I tried to use anything slightly abrasive on it. And it's only when you look closely you can see the scratching at all. But took those silly brackets off, and slightly annoyingly you're left with a big whatever you call it there, which looks a bit not very nice, but not much I can do about that. Similarly on the other side, but you won't see that when it's up on the bench. Well, I suppose I ought to contemplate taking it apart. Okay, let's see how hard that is to do. That's was fairly easy. It's just 2 screws on there, on here, to take this piece off, and then there's another couple of screws there, and the whole thing should slide off, which is good. Yeah, here it is. Two transformers. Maybe one's for analog and one's for digital. Who knows? And what I'm most interested in is the display, which of course is at the back there, at the front there. And that tells me nothing at all without taking it further apart, which I don't really want to do. Although I'm sure it's easier than taking the HP 34401 multimeter apart. That is an absolute nightmare to get the front panel off. And there may be some chips on the front panel, I don't know, but what I do know is if you want to take it apart, these come off, these terminals just pull off, so that makes it quite easy. And then there's a ribbon cable that goes up to here, which is data for the display. So I'm guessing there's some sort of a chip on there which does the display decoding. I might see how hard it is to get the front panel off. And what else can you say about it? Nice long plastic lever for the power. No, it's not the power. That's the front and rear terminal switch. That's what that is. And loads of complicated electronics, none of which I understand. I can understand the power supply bit, but the rest of it's a mystery. Oh, there's the squeaker. And that, I'm guessing, is a voltage reference, which wobbles, as it did in the video I watched on YouTube with somebody who had one. His wobbled as well. So it must be a reason to wobble. Doesn't look that hard to get the front panel off. I'll have a go at that. I'm not going to do it on camera. Well, getting that apart was quite easy compared certainly to the HP 890, whatever it's called, 834001. And here we have it, the front panel. And one thing that's interesting though is this wire, which I haven't, the current meter wire, current wire is, because it's crimped on and I don't want to uncrimp it. But oh, look at the rust. That is quite horrible. So that needs a bit of attention. What do I do? I suppose the spring doesn't matter if it's rusty, but I think that needs cleaning up. That makes contact with the fuse. So I'll clean that up at some point before I put it back together. But as for the display, well, makes no sense whatsoever to me. We've got a display, we've got chips. They're probably display driver chips and some more chips everywhere, and I haven't got a clue what they do. So the display fault is either the vacuum fluorescent or one of these chips, and I don't think I'm going to be looking at changing any of that. Not only is it possible that you cannot even get one of these anymore. It says Motorola something. Maybe a microprocessor. I don't do microprocessors. But I can clean this anyway. Is there much point there? I don't think it's that bad. No, I think it's time to clean off the rust and put it all back together. That's about all I can do with it. Then I've got to learn how to use the THD bit. And I hate reading off computer screens. I'm going to have to print out that bit. Anyway, let's get it back together. Right, it's all back together. Display went back together fairly easily. Cleaned up the rust. I even got some of the rust off the spring, which is always good, isn't it? Now, before I go any further and put it back in its box, I want to see if it still works, and more importantly that all the buttons still work, because of disconnecting, taking the display off the rubber keypad. Well, it still squeaks loudly enough. DC volts, AC volts, DC volts, AC amps, AC whatever, ohms, frequency, temperature, still there. As long as it squeaks, that's what I care about. It means the buttons are working. Well, this is a way to turn off that squeak. I don't really mind that. I've got some rust on the auto button. Get the rust off the auto button, that's most important. And what else am I doing? All the rust off. Yeah, all buttons work. Shift, that works. Local, whatever. Turn the power off, get it back in its box and put it in its new home. So there it is then, back in its new home. And when I realised I'd won the auction, which was about 5 days ago, I thought I'd better make a shelf up, so I've got a new shelf. And I thought it would be sticking out too far, but it actually doesn't stick out as far as the HP, but it is fairly disappointing, that display. Certainly readable, but not how it should be, I'm sure. But it's still usable. So I think I'm going to finish this video now, and when I've learned how to do THD on it, I might do a video on that. Anyway, Keithley 2015, a classic 6.5 digit multimeter. Bye for now.